Well, thank you all for sticking around for the final session of this wonderful conference. I'll change it up a little bit, wake everybody up. I want to know how many people this morning use the water in their home or hotel room? Okay, how many of you ever wondered where does it all go? Not everybody wonders where it goes, but you do pay a tax to handle it. So what I'm talking about today is how Chicago's executive director and management chose a strategic plan and environmental management system to lead them to composting. So it was very exciting to hear about what's going on in the state of Florida with Karen, and then the thermal hydrolysis process that Mackenzie talked about, because she also talked about triple bottom line approach, or triple, I don't know, how did you? Triple impact approach. Yes, so we're going to talk a little bit about that as well today. So if you ever wondered where your material goes when it leaves your home, it goes to a wastewater treatment facility. All the solids that comes out of that water must be dealt with in one way, shape, or form. And in Chicago, where I worked for over 30 years, we did it the same way from before I arrived until the day I left, with some little changes with Biosolids master planning. So it's not always good to say, this is the way we've always done it. I mean, technology's changed, thermal hydrolysis is here, composting is here, so what are we doing to better ourselves? So today we're going to talk a little bit about that approach to the Stickney and Calumet plants, which are generating well over 130,000 tons of dry tons of product a year. So all of the product in Chicago is anaerobically digested, and from there it either goes to a low solid lagoon. Let's try this. Okay, so it enters the low solid lagoon at roughly 3% solids, or it goes to a centrifuge at 3% solids. The difference is when it comes out of that lagoon, it's 10% solids. So we still have to dry it. So we outload it into a truck, bring it to a drying site, and then we further process it with equipment. The other process is centrifuging, where we're adding polymer, we're getting rid of that water, and we're in the neighborhood of 25% solids coming out. We load it onto a truck or a train, and we bring it to a lagoon where we further process it. Now, Chicago's pretty big. We have a large population. We have 18 lagoons storing 4.5 million cubic yards of sludges. Some of that is low solids, and some of that is the cake that comes out of the centrifuge, as you can see in the lower right-hand corner there. This is one of my favorite pictures. This is one of 7 drying sites that we have, where we dry the biosolids from that 10% or 25% solids to 60% solids or higher before it goes out to a farm, or if it tests out for Class A, we'll ship it to golf courses. We'll ship it to, high schools, park districts, whoever would like to have the organic matter put back into their fields. The problem with this is we have 390 acres. So you think of throughout the city of Chicago, we have 7 drying sites, almost 400 acres. It looks like the whole city had dysentery at the same time all summer long. So you can imagine any neighborhood around these facilities trying to have a picnic on the weekends, we have some issues. So, but here's our process. You can see in that upper left-hand corner, it's just a bulldozer with a railroad tie tied behind it, running through this sludge, turning it over till it gets a little bit thicker, and then we have farm equipment. It's basically a rotavator on the back, churning it up, throwing it up in the air, just similar to you in the bathroom, drying your hands under an air dryer. That's the same process we're using with a brown bear. And then, of course, in the end, we're going to stockpile it with a loader and then screen it before it goes out. One of the things that we always say is we don't need to change anything. We have a 30-plus year award-winning Class B land application program in the state of Illinois. It's also a Class A program, so some of it goes out as Class A. So why do we need to change anything? Well, golf courses are great. We built this one. It's called Harborside International on the south side of Chicago. It held a senior PGA tour. Has over 500,000 cubic yards of material in there. So we do have great uses for it. This is my favorite slide as the manager of the program years ago. Every leaf that you see there depicts an area where we would haul our biosolids to for use as a Class A. not a Class B. Class B would even go further away from our plants to farmers. But you can see we have to go pretty far out, all the way to the ends of the county. So our trucking costs are high, our carbon footprint is high, and with those 390 acres of air drying at 7 different locations, our carbon footprint is high because of all the non-tier 4 equipment that we have driving around doing that work. So I'm laying the groundwork for this slide. So we have all the costs, the carbon footprint, but we also come into a lot of pressure from people who don't trust the governmental agencies. There's PFAS, there's heavy metals, there's pharmaceuticals, there's all kinds of contaminants in our biosolids, in our organic matter that we're trying to process, convince you to use on your front lawn. So we have that. We have increasing bans on land application due to those contaminants. And then again, just other concerns, the ick factor, I like to call it. People, if it's poop, they don't want it. Why are you putting that in my backyard? Let's incinerate it. Let's do something different. So with that in mind, back in 2000, we entered into an agreement with the National Biosolids Partnership, which is a division of the Water Environment Federation. And I'm trying, hopefully over the next few years, we're going to start to tie the Water Environment Federation, the new Florida Composting Council, and what you guys do here. Bring it all together to better serve our environment as a whole. But the whole idea of the National Biosolids Partnership is to create an environmental management system that anybody can use. So if any of you use a management program in your business, you know that you're setting goals and objectives, you're striving to be better, you're looking for continual improvement. Well, that's what the National Biosolids Partnership Program does for us. It has 17 elements that we need to look at and try to find improvement in. It could be public relations, it could be efficiencies, it could be anything. So going back to my schematic earlier, and I'm going to send these all to Mackenzie to update so it's more modernized. So, but every star, think of your own process. How many moving parts do you have in your process? Every star depicts an operation, part of our operation that we needed to take a look at and say, how could we improve? Do we have odors here? Are we having a negative environmental impact with anything that we're doing here? What are our costs associated with each thing, and how could we improve? So with that in mind, we set a strategic plan to add value to our biosolids program. We're just giving it away, or we're paying people to take it. Landfills, we had to pay a tipping fee at the landfill to take our final cover, which had more restrictions than land application, and we're paying the landfill to take it. So we wanted to help increase resource recovery. Biosolids is a resource. If it's not contaminated with PFAS or pharmaceuticals or those heavy metals or other these micro constituents, we have a resource that could be utilized. So we wanted to also lead partnerships within within Cook County to better the environment. So we started to look at alternatives to our 400 acres of drying, and these are just some of the technologies that we took a look at. And as I get further in and talk about the program, we're getting into what Mackenzie alluded to earlier, a triple bottom line approach. Years past, they said, Dan, you're the biosolids manager, you come up with a way to improve the program. So every year you're trying to do that, but then it goes up to your bosses and they say, well, we don't have money for that. You're a governmental agency, we're gonna go with the low bidder. We had a newer executive director, he said, no more is one person gonna make a decision. We need to have a holistic approach to what we're doing. So let's bring our engineering team together with our researchers, our scientists, M&R, with the operators and those in maintenance, along with our finance and procurement and material management folks. So we had a whole team of people that were going to evaluate those different technologies. So that was important for me. So again, alluding to the triple bottom line approach, we also evaluated economic criteria, technology, and environmental and social criteria. For everybody in this room, even if you did biosolids just like I'm doing it, your criteria is going to be different from mine, or it could be the same. So my end result, while it comes out one way, our short list was heat drying and composting. You may come up with thermal hydrolysis because that's what was best for you in your criteria. So while I come up with a conclusion for me, it's not what's best for you necessarily. So once we use that triple bottom line approach, took a look at heat drying. We said, okay, why does heat drying have an advantage over composting? We chose those two, but why go one way or another? Well, we knew that heat drying has good odor control. It's going to make a nice pellet, and pellets are great to market, so we have a Class A product that we can bag, and we can market and make some money on, or I hate to say make money on, I call it, you're going to recover cost. So that was a big deal for me. Is they always say potential for revenue. The revenue is just going to cover the cost of production, which is well over $400 or $500 a dry ton. In addition to that, we're already operating a heat drying facility at our Stickney plant that handled 40,000 dry tons. So why not build another one there and another one at the Calumet facility to handle what we're already doing? Composting, on the other hand, also had advantages. Pretty much the same. We're going to produce a high quality Class A product, has good odor control if you do it right. You can store it without quality degradation. And what does that mean? Pellets, if they get re-wet when we store them, they have the high potential for odor. If any of you have used Milorganite, when you put it on your lawn and you water, you initially get a nice odor associated with that fertilizer. And again, it's a socially accepted practice, and we're going to have a potential for revenue with the compost. When we put everything back in our triple bottom line approach, we find that composting came out on top. Far exceeded our air drying process, which we deemed be very antiquated. We needed to move on, which we already knew, but when we compared it to heat drying, it was lower than that and obviously lower than the composting. But did composting meet the strategic goals and environmental management system goals? And the answer was yes. We're going to add value by creating a Class A product that we could market. We're going to increase resource recovery because now we're going to work with the city of Chicago and outlying small businesses to bring in feedstocks to mix with our biosolids to create that composted product. And then we have a potential to lead partnerships, because with those partnerships we can bag the product. We already have the pelletizing facility that does bag some of their product. We already talked to them about, hey, if we do this, will you bag it for us? And of course, with the contract and money, they said yes. So we're pretty excited about that. And we also derived a resource recovery ordinance in the city of Chicago, which allowed for the city to bring yard waste to us, and also for mom and pop to bring from their landscape operations, bring material to us as well. So we'll get into that later. But did it meet our environmental management system goals, which was my end of things? I wanted to reduce overall costs and our carbon footprint. Composting would do that. One of our sites was 70 acres, the Calumet facility. So when we put in the composting system, we're going to drop it down to about 10 acres total. So 60 acres are going to be made available for lease. For example, one of the facilities that got shut down when we put in the heat drying facility was a 100-acre facility. We now lease, for the last 15 years, that property to Ford, which is right down the street from us. They lease all 100 acres, so it's a great revenue stream for us that they store cars on that facility. So when you think of why you pay so much for your Ford, now you know they have to pay somebody else to store those cars while they're waiting to be used. So, and the other thing we wanted to do is, if you remember that leaf slide where I showed you where we're hauling all the Class A biosolids to, it was pretty far away. So if we make more Class A, people are going to want to come pick it up. They're going to want to use it. And we knew if we just did a free giveaway of that product, we're going to reduce our trucking costs and reduce our carbon footprint. So what was made clear early on was that we were going to compost. But how are we going to do that? A lot of you know that there are many ways to compost. You can cover it, you can push negative air, positive air, you can put it in a building. Well, for the Stickney plant, did not have any odor complaints. We were kind of out in the middle of nowhere, and the process where we wanted to do the composting, we knew we could do it because we didn't have any issues. So we went with open windrow. So all we had to do was buy equipment to do that. The Calumet plant was a little bit different. I had managed that facility for years, and our executive director promised the local community that somehow we were going to cover the biosolids operation so we would reduce odors, reduce dust, and create a better environment for them, for their basically their backyard. So we needed to consider what type of enclosure that we would use for the Calumet region, and we chose a building, covered aerated static pile, or in-vessel composting. So now we had to go back and evaluate those technologies. So we kept doing these analysis, and it took a couple of years to get through this process. This didn't happen overnight. So when we did all this, we really realized composting in a building has some great advantages. We could do windrow inside of a building, or you could do negative or positive aeration inside of a building. So it was very versatile on what you can do, and you could reclaim the heat from composting in a building and use that heat somewhere else. So the disadvantages is once you build that building for X amount of tons of product, it's not scalable. If you grow, if your population grows, you have more solids to deal with, now you got to build another building. Those capital costs were between 60 and 70 million. Our operators, so another facet of that team, they said, listen, we work outside. We like to work outside. You put us in a building with all that formic and acetic acid, that ammonia, we're not going to be too happy. In addition to that, we're going to raise our maintenance costs because of the corrosion that occurs because of those factors. Now, covered aerated static piling also has advantages and disadvantages. Some of those are covered, whether it's, if you have a semi-permeable membrane cover or a non-permeable cover or a wood chip cover, final compost cover, you could do negative aeration with a biofilter, or you could do positive aeration, so it's very versatile on what you can do. It's a lower overall cost than building in a building or in vessel, and it has the ability to easily control the odors with that biofilter or with other means. The disadvantages are if you buy a membrane cover, they're pretty darn expensive to replace every few years. With wood chips or a final compost cover, you need a lot of it to satisfy the EPA that this is a suitable cover. We found that we tried that. It was very inconsistent with our wheel loader operators that tried to get 12 to 18 inches of cover on compost day in and day out. So our executive director said, well, that's not going to happen. You need to go with in-vessel or in-building or a different type of cover. So in-vessel composting was something that I really liked a lot. It was clean, had some great advantages, had a lot greater control over the entire process, the composting process, and we had to use a lot less bulking material because now you have to bring in that wood chip. So you have to buy it, you have to get it from somewhere. So I like the fact that we had to use less. It had a lot smaller footprint than putting it in a building, so that was good as well, even though we had 400 acres outside that we could deal with. The only problem was the capital costs left a little bit to be desired at 104 to 150 million. So when we took a look at our present value analysis of those three technologies, composting in a building and the compost covers were pretty comparable, and the composting in vessel was kind of taking a back seat due to its high cost. But when you look at your triple bottom line approach of what's important to the company, money doesn't always trump everything. I mean, used to low budget, you take when you work for a governmental agency, if it meets the spec, you're going with the lowest bidder. Here, you can see that while covered composting exceeded the two other in-building and in-vessel composting, the in-vessel composting, due to its other advantages, reached the same output as far as the triple bottom line approach did with building composting. So that's something that we continue to use, is the triple bottom line analysis, because although something could be very costly as far as monetary, with your other criteria that's important, you may end up going with the most expensive option for you. However, we weren't done, had to do another pilot. They said, okay, Dan, you decided on the type of covered composting. How are you going to move forward? What kind of cover do you want? I don't know. I just want to compost now. We knew we wanted to do windrow composting at the one facility, so we just bought the equipment. That was very easy. We had it, within 12 months. For some of you who say that's a long time, well, that's the way budgets go when you work for a governmental agency. It takes at least a year. You got to get into the budget, and then you have to buy it. So, However, for Calumet, we went with a covered technology. We were told by the board we needed to do side-by-side pilot testing to see which one we would prefer. And then at the same time, while we're doing that pilot test, obtain capital and operational cost, CapEx, OpEx examples, and then on-site design, what would it look like? So our pilot testing, we used a non-permeable membrane cover, which we were directed to use, and then a semi-permeable membrane cover. And both of those were positive air. The difference is the semi-permeable membrane cover is a breathable material. There's a couple different covers out there. And then a non-permeable was basically like a plastic bag that had a biofilter on the other side to scrub the odors. The semi-permeable membrane won out simply because the non-permeable membrane plastic bag or saran wrap, it didn't really work too well. How do I go back? There, you can see a computer inside the bubble there. So number one, the pressure was always on, but for whatever reason, it wasn't breathing right, and we never were able to get the temperatures up. So we ended up creating a stink bomb, even though we had the biofilter. The semi-permeable membrane cover, we were able to reproduce the results over and over again to a point where our soil scientists were saying, okay, the ratios were 1-to-1 by weight, or 1-to-3 by volume. So 1 part biosolids to 3 parts wood chips. They're like, well, let's see how little wood chips we could put in there and still get the porosity we need for composting. So we were able to keep playing with those covers and still achieving positive results. So we went with that semi-permeable membrane with positive aeration. So the summary of the program today, we formed an intergovernmental agreement with the City of Chicago for resource recovery of all the wood chips from their operations. So to date, they brought in well over 100,000 cubic yards of vegetative matter to us. And we also have a resource recovery ordinance which covers fats, oils, and greases. It covers, all the small landscape operations, mom and pop. They could bring all their wood chips to us if they deem it not too far to go to. That way they're not paying a tipping fee at the landfill. We have 9 active suppliers, sometimes a little bit more, but they have to sign off that they're bringing us clean fill. We don't ship it. It all has to be ground when it comes to us. So that's great. We've received 40,000 yards in that fashion, with another 10,000 yards coming through a pay program where if it's grasses or anything that's pretty live, it has its own issues of odor and flies and other vectors. So we charge $10 a yard for that. So we're getting money for that. But finished compost, we've generated well over 100,000 tons of finished compost now. Farmers love it. However, not a lot goes to farmers unless it's really close to residences. But we have a pickup program. We can't put it in the bins fast enough outside of the plants, and you have cars lined up every, whatever plant we put it at, Monday, Tuesday, Wednesday, it doesn't matter. They're lined up to fill their buckets or their pickup trucks every day we put it out there. So we're using our compost as a soil amendment. It's been registered, and we're waiting for approval from the United States Composting Council to give us a STA number. This is my favorite slide. Basically, when I went back after retired for our Christmas party, the staff gave me a bag. They're bagging it now. It's called Exceptional Quality Compost. So the program went from just mixing it with buckets to now we have a bagged product. It's used in community gardens throughout the city of Chicago to grow vegetables in different communities. The land in Chicago has a lot of lead in it, so a lot of folks are creating raised beds, and they're putting our compost in it, and they're growing vegetables in it to feed people. So I think that's great. And in addition, we're improving the landscape as well by growing, allowing people to take it and grow flowers. We deliver it still free of charge. We don't sell it. It's all free giveaway. And if you are ever in the city of Chicago and you want to see a good use of, good resource recovery, go to Maggie Daly Park. It's right in the heart of the city. Anything green here at this park has been grown in biosolids, amended soils, or biosolids composted biosolids, amended soils. They have picnics there. They have lawn concerts there. So the ick factor has really reduced over the years because of how we treat it. And It took time. I've been retired 7 years, so this is 10 years in. So to improve your program and go after continual improvement and change your process doesn't happen overnight. And as Karen alluded to, they're working on changing some of the compost regulations in the state of Florida. I'm working with the Florida Composting Council on that. So I hope to see more of the biosolids operations. I think Karen said there was like 5. So I'm hoping to see that number change and be able to report back to you guys what's happening actually in the state of Florida rather than Chicago the next time I come back. So thank you for your attention. Thank you for being here, and thank you for all the staff for all the work to put all this together. So I think we're available for any questions now.